Hello everyone, so today we're going to build a LED Christmas ball. The idea is to actually build a small sphere, white sphere, and place some LEDs inside with a microcontroller and then print a ball around it. So what you're seeing on the screen is what we're going to do right now today. I'm not going to launch into a long-winded discussion about Fusion 360, but the Christmas ball was designed in Fusion 360, and it consists in a Christmas ball with a sphere inside, and the sphere is split in two, and the Christmas ball is actually printed around the sphere. So what we're going to do is we're going to print the sphere, install the Arduino and the LEDs inside of the sphere, and then and only then will we print the actual Christmas ball, which is the gold part that you can see on the screen. So the first thing we're going to do is we're going to actually connect 7 LEDs around the Arduino, and we'll glue that LED strip to the inside of the sphere, and then we will glue the sphere and it will hold the Arduino. And then we will start printing that gold part, and midway through it, what we'll do is we'll stop the printer, we'll place the sphere inside of the Christmas ball. The Christmas ball is this blue thing, and the sphere is the inside of the Christmas ball. That ring is going to be holding the 7 LEDs, which are going to be on the LED strip. The electronic circuit for this project is extremely simple. It consists in an Arduino Nano, as well as 3 wires that connect to an LED strip. I cut the LED strip to contain only 7 LEDs. The circuit is shown on the screen, but it's much simpler than that, because in fact the 7 LEDs are actually coming pre-soldered on the strip. So you can buy any WS2811 or 2812B strip as long as it has 60 LEDs per meter. The walls of the sphere need to be very thin, because they need to be able to diffuse the light of the 7 LEDs. Yet the base has to be strong, because it is actually holding the entire Christmas ball inside of the Christmas tree. So I had to do some trade-offs there. I chose to use only 7 LEDs because I wanted to limit the amperage on the Arduino Nano board, which does not like to provide more than about 200, maybe 300 milliamps. Each one of the LEDs is actually drawing a substantial amount of current, and so 7 LEDs seemed perfect in order to keep the LED current requirement under about 100 milliamps, and we're going to check that at the end of this video. And we also needed to have only 7 LEDs because the strip could not be much longer than 120 millimeters, because we want to keep the Christmas ball within the sizes, which is usually between 50 and 65 millimeters on Christmas trees. So on each strip we're going to add the plus. In the middle we're going to add the data cable, and the last one is going to be the ground. And so for the VCC, for the 5 volt, I'm going to solder a red wire, if I can. For the data, I'm going to solder a yellow wire. And for the last one, I'm going to solder the ground wire is going to be a white wire. The last thing I want to do is actually find out that it doesn't work after I've actually closed the Christmas ball. So, all right. So they're holding, they're tight. Okay, good. All right, and now we get the Arduino Nano board, which has a voltage in. We're not going to use this. We need voltage out. A voltage out, which is the 5V. So we're going to use the 5V, and it has a ground. So 5V and ground. So it's going to be a red wire, white wire, and the other side, we have right next to the processor, we have a pin D7. So D7 is going to be our data. I want my data cable to be short because I do not want too much cable inside of the Christmas balls. Now we can test the two LED strips. Okay, so red, it's perfect. It turns green. So we're done with this one. And now we're going to test the second one. And that's perfect. And now we're ready to glue them. So I'm going to glue both of them, and I'm going to remove the tape. I'm applying a gentle pressure on each one of the LEDs. Right. And now we have 7 LEDs, and the only thing we have to do is close this. There we go, and we're ready, and we're going to glue this. And I'm going to do the same thing on the other one. So that now that we have completed the circuit, the electronic circuit for the Christmas ball, we need to program the Arduino. There are two ways to do so. The first way to do it is to use the Arduino IDE. This is the latest one, the Arduino IDE 2. Something. So this one is a 2.2.1. If you still have the old one, it might be a tiny bit different, the 1 point something. The new one has these icons on the side. You need to open the library manager, and once you have started the library manager, you need to look for a Fast LED by Daniel Garcia, not the other ones. You need this one. It's already installed for me. If I did not have it installed on my computer, instead of the remove button, I would have an install button like so. So this is the first way to do it. If you use the Arduino IDE, you're going to need to select the Arduino Uno board with the board manager, and it's going to show up here. Arduino Uno, or Arduino, in this case, it's going to be Arduino Nano. So we want the Arduino Nano, and in fact, once we plug the Arduino to our PC, we're going to be able to select the port. For the processor, we want the 80 mega 328P. In some cases, like the iLetGo Arduino Nano clones, like the one I've used, you're going to have to select the old bootloader. Now, the other option is to use Visual Studio Code. To install the FastLED library for Arduino in Visual Studio Code, you need to use the PlatformIO IDE extension. So the steps are as follows. The first step is to install Visual Studio Code. If you haven't done already, you can download it from https://code.visualstudio.com. The next thing you need to open the Visual Studio Code. You need to go to the extension. So it's going to actually look exactly like what I just showed you on the Arduino IDE. On this one, what we're going to look for is we're going to look for the PlatformIO IDE. So this PlatformIO IDE is what you need to program all the Arduinos and all that good stuff. So we're going to install that. I just uninstalled it, so we'll see if it works. Might be interesting. All right, so installing, perfect. So the next step is we need to restart the Visual Studio Code IDE. So I'm gonna go and do so. And all right, so once we've restarted Visual Studio Code, we need to click on that alien face, and it's going to install the PlatformIO core. Okay, we're done. So now what you need to do is we need to restart Visual Studio Code one more time. And now we go to PlatformIO core. It's going to initialize it one more time. We need to go to the libraries. And we're going to look for FastLED. Fast LED, search. And that's the same one, FastLED by Daniel Garcia. So that's the one we want, not the other ones again. So we're installing it. Okay, so once we restart Visual Studio Code, we can go to the PlatformIO. It's going to initialize the PlatformIO core. We're going to create a new project. The project name is going to be LED Christmas Ball. LED Christmas Ball test. I'm going to select Arduino Nano 80 mega 328. My framework is Arduino, and the folder name is going to be LED ball test. Now I can use Copilot to do it. So Control-I, write a program for fast LED for Arduino Nano. I accept. All right, so this is not good. I want 7. I have pin 7. We have 7 LEDs. We are running on the WS2811. Generally, I don't know why it selected the GRB, which is correct, but generally it would be RGB. In my case, it is. So colors. Define colors GRB. Okay, it knows. So this is not good. I don't want this. I want something more dynamic, so I'm going to use static. I'm going to change the U. Okay, it already knows that. That's quite amazing. That's what I was going to type. And now for integer, right, that's exactly what I want to do. I want to change the U. But now we need to show. So that's going to be fast LED show. Yeah, exactly. And then we want a delay. So I want a delay of 5 milliseconds between color changes. There you go. Ah, come on. All right, to compile, we go here, we do build. And that's a build. There you go. So that's built. Success, 2.47 seconds, and upload. So sometimes there are problems here. It depends what kind of bootloader you have. If you have the wrong bootloader, there's plenty of websites on the internet to explain what's going on. Okay, so we're done. We've actually coded the program. I'm going to provide another one more complete so that the Christmas ball changes colors. But that's it. You can download my INO file for the Arduino IDE, which I'll post on printables.com. So if we forget the PlatformIO IDE for 1 second, what we also can use is the Arduino for Visual Studio Code extension, which is provided by Microsoft. Behind the scene, the Arduino for Visual Studio extension uses the Arduino command line tools, which are provided with the Arduino IDE 2.0 and later. So basically what you're getting is the command line build and compile tools of the Arduino IDE, but you're actually changing the IDE, but you're keeping everything else. So you're switching from the Arduino IDE to the Microsoft Visual Studio Code IDE without changing the build tools. We open one of my workspaces that I've actually used. So this is actually the final code, the code that I've put on printables.com. We see that we are actually working inside of the Visual Studio Code, but we're actually using the Arduino IDE backend tools, the Arduino CLI, as it's called. And so if we're actually doing a compile, so that's the verify button of the Arduino IDE, or the equivalent of it. And we have the upload as well. I do not have a board connected at this point, so the upload would actually fail. I need to add one more thing, which is important, is that in the Arduino.json, you have the configuration. So what you want to use is the COM port. So in my case, it's COM port 8 at this time. You're going to have the sketch, and you need to specify a build output. If you do not specify a build output, it's going to be very slow because it's going to rebuild everything from scratch every time, the compiler. And one thing, which is if you're using a clone, iLetGo, or if you're using a Elegu clone of the Arduino Nano, you're going to have to use 80 mega 328 old. So that's the important parameter. I need to add one more thing. If we are in the Arduino IDE and we need to specify the port, in this case, I actually moved the Christmas ball from COM5 to COM6 to show you. So it might be wrongly selected here. So I'm going to push it to COM6. Here you go. I just send it to COM6, and now we can compile the sketch, and it's gonna work. If you do not know where the Christmas ball Arduino board was located. You can find it in computer management. So computer management and then device manager, and it's going to show in the ports, common LPT line printers. So I have a USB serial CH340. So that's the Chinese clones of the Raspberry Arduino Nano boards. They use this CH340 chip for communication. So it's detected as a CH340 on COM6. At the end of the project, we simply check the current load, which again is limited to about 200, maybe 250 milliamps on an Arduino Nano on the plus 5 volt pin. I put the schematics as well as the Arduino Nano documentation in the description of the video below. The black draws only 15 milliamps, meaning basically when it's off, the Arduino board draws 15 milliamps. The white draws 60, which is normal because the red, green, and blue are on to make white. The red alone draws 30, the green alone draws about 20, and the blue alone draws about 30 milliamps. So we are well within the limits of the Arduino board with 7 LEDs. Once we have assembled the Christmas sphere, we can place the Christmas sphere inside of the first half of the Christmas ball. And we need to stop the print at about 52 millimeter height because the Christmas sphere is about 50 millimeter in height. We have to place it very carefully because if we're not careful, when we resume the print, we're going to have artifacts. We're going to have lines along the arches of the Christmas ball. So I place a tiny weight on top of the Christmas ball in order to keep it down while the epoxy glue is curing. And next, I have to check that the sphere is not protruding above the current level of the Christmas ball, because when I resume the print, I want to make absolutely sure that the printer head is not going to be impeded in its movements by the Christmas sphere. And so once the glue has actually cured for about 20 minutes, I can resume the print. And this is the print resuming. It has actually printed about 10 millimeter on top of the height that it had when I stopped the print. We need to have arches in order to be able to resume the print. If we did not have arches, as you can see right now on the screen, we would have terrible artifacts along the lines of the Christmas ball. So it would not look good, so I added those arches.